Sammy Oliver. My lab number is 812.
I'm Mariah, lab number 307.
I'm Felicity, and my lab number is 807.
I'm Kaylee, and I'm 312.
Today, we are going to tell you all about water, its uniqueness, and why it is vital to us.
Water really is one of the strangest substances known to science because of its qualities. This may seem like an odd thing to say because it's something we all see as so simple, but it's true.
Water-specific heat and surface tension, and most of the other physical properties and values that are much higher or lower than what normal of those and any other known material. The fact is that its solid phase is less dense than its liquid phase, which can be explained by ice floating in water, is such a unique property. These strange properties make water a uniquely useful substance and the basis for living things.
Its vitality to life is that water is used to fuel and hydrate our bodies as humans and other animals.
Our bodies are made up of more than 60% of water.
Water is something we need to live! In today's lesson, we will be learning about melting point, boiling point, and all of the states of matter.
Yay!
Now, who can tell me all of the states of matter and what their points are?
I know.
Okay.
Okay, so the first one is solid, known as ice. The second one is aqueous form, known as water. And the third one is gas, known as steam.
Very good. Yeah. Now, who can tell me the melting point of ice?
Oh, me!
Yes?
It is 32 degrees Fahrenheit.
Very good. Now, let's just go to the pan. Look, it's starting to melt, and it looks, it's really cold. And it's very cold. Now, we shall wait for it to go into the next part. I need to turn that up. Now, who can tell me the boiling point of water?
Oh, me!
Yes, Mariah?
I believe it is 212 degrees Fahrenheit.
Correct! Now, very good.
Ooh, I see bubbles.
Yes, it's done! It's finally done. We've created boiling point out of ice water. Congratulations, class. We are now going on to the next topic.
This is the molecular structure of water.
As you can see, there are 2 hydrogen for each oxygen. Wait, that's carbon dioxide. This leads to hydrogen bonding. Hydrogen bonding is when a hydrogen atom is attracted by strong forces of 2 atoms compared to the only one, so that it can act as a bond between the 2.
We can also tell you about polar covalence.
What? Oh, that's me! The covalent bond is formed by the complete transfer of valence electrons between bonded atoms. Such type of bonds are formed by the equal sharing of electrons between 2 bonded atoms.
In water molecules, 1 atom of oxygen is with 2 atoms of hydrogen. The oxygen has 6 electrons in its valence shell. It shares with 2 hydrogen atoms to complete its outer shell with 8, making it full.
As we go through these lessons, you will also want to know the heat of fusion.
The heat of fusion is defined as the amount of heat necessary to melt or freeze 1 mole of a substance at its melting point. Although, we also want to tell you about effluence and desiccants.
Effluence is also water. It can happen in natural or artificially built scenarios. While desiccants is a substance that induces or sustains the state of dryness in a vicinity.
An example of a desiccant is the little silicone gel packets you find in your clothing.
Whoa, really?
Yeah.
Why?
Chemistry.
Oh, okay. That's awesome.
And we can cut this off a little piece. You crawl into the camera.
I'm dropping it! Here we have a wild Sammy in her natural habitat.
Okay, now please, take a moment to appreciate this historic moment, as for the first time ever, we have a wild Sammy caught on camera with her water bottle.
We're just off balance of her entire life.
We are about to introduce water suspension into her life.
Ooh.
Look, she goes down. We have a small window of opportunity to mess with her.
we like to call water suspension.
Dun, 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 dun! It's Science Sammy!
We're going to tell you about universal solvents and solids, as well as electrolytes and non-electrolytes.
Water is considered a universal solvent because it dissolves more things than any other liquid.
And a universal solute is a substance that can be dissolved in pretty much everything.
We're also going to tell you about the solution process.
A solution is formed when one substance completely dissolves into another.
Excluding gases, all solutions go through a condensed phase.
Electrolytes are substances that produce ions in a solution. If they completely dissolve, they are strong electrolytes.
But if they only partially dissolve, then they're weaklings.
But if they don't dissolve at all, then they're just non-electrolytes.
No!
We're going to be doing a lab over the Tyndall effect, and we're also going to be learning about colloids.
You may be wondering what the Tyndall effect is.
The Tyndall effect is the effect of light scattering in many different directions throughout many different solutions.
You can tell whether it's a colloid or not by shining a light through it.
You may be wondering what a colloid is.
Colloids are uniform mixtures that don't separate or settle out. There are two parts to every colloid mixture, the particle and the dispersing medium. The colloid particles are solids or liquids that are suspended in the medium itself.
In the lab, we will demonstrate how to tell the difference. First, what you have to do is get 2 clear glasses and a flashlight.
First, and then, you first fill the first cup with water. Then the second one with milk. Then, you need to use a light from your flashlight to see what happens.
You might want to turn off the lights so you can see this better.
When you shine it through the water, the light is not reflected when passing through the water because it's not a colloid.
When you shine it through the milk, it is reflected in all directions because the milk itself is a colloid.
And that's for this experience. Wow, experience.
That's for this experience.
That's it for this experiment. Now we're going to be talking about specific heat capacity and specific heat formula and what it's measured in.
It's going to be measured in calories, which is just a simple unit of energy. It's about 4 joules.
Are you calling me fat?
She's not calling you fat. A joule is another common unit of energy used in physical sciences.
Although these calories
Capitalized.
shouldn't be confused with the ones on the food packaging.
Lowercase.
Those are actually kilocalories.
The word is sometimes capitalized to show the difference, but it is more often than not.
Now for specific heat. Water has a very high specific heat capacity.
The specific heat of water is the amount of heat needed to raise its temperature a certain amount. One of water's unique properties is that it takes a lot of heat to get hot. Water has to absorb 4.18 joules of heat for the temperature of 1 gram of water to increase 1 degree Celsius.
Or exactly 1 calorie per gram. Next we talk about specific heat formula.
This specific heat formula is used to find specific heat. It's pretty self-explanatory unless you're like some stupid git or something. It is calculated like this. By placing the amount of heat over the mass of the sample multiplied by the change in temperature.
Is it like 3.21 gigawatts?
Joules.
Oh.
Joules.
Okay.
Cut. We're going to be doing an experiment over Brownian motion.
Brownian motion is the result of collisions between small microscopic particles
Brownie in motion!
and the invisible but constantly moving water or air particles surrounding them.
You need 1 cold glass and 1 hot glass of water.
Then you put 2 to 3 drops of food coloring in the cold glass of water.
What you're going to see is that the coloring will mostly stay together and slowly sink to the bottom.
Then you put 2 to 3 drops of food coloring in hot water.
What you should now see is that the water quickly takes the coloring and begins mixing it in before it even gets to the bottom of the glass.
Why does it work like this? Well, it works because water is made up of tons of tiny little particles.
The particles in the hot water are more excited, so they move faster.
All the little collisions are either sped up or slowed down simply because of the temperature of the water. And now you'll see that this is completely mixed together and these are still holding itself together.
Now for the fun part. It's the Hulk!
And doing a lap over the surface tension of water.
You may be asking, what is surface tension?
Surface tension is where the surface of a liquid is strong. The surface can hold up a weight, and the surface of a droplet holds the water droplet together.
To start the experiment, you need 2 glasses filled up about the same amount, 2 identical paper balls, a spoon, and some dish soap.
Firstly, the water must be even. Then, you pour the dish soap into one and mix.
Then you take the 2 pieces of paper and make them into identical balls. Then you drop one into each.
You should see that the paper reacts differently with each glass. The one with the dish soap sinks because it has less surface tension.
They just can't hold up much. It's just so awesome. Well, this one just held it all up, and this one just went.
Cool.
It's so awesome.
Today, we will be doing a water hydration experiment. Now, class, shall we hydrate salt?
Sugar.
Okay, we can do sugar. Okay, now my assistant will fill the glass of water with the sugar.
I shall stir the mixture and create sugar water. Dissolve!
Not done yet. So now she's created a hydrous mixture?
Yes, she has. Now, how will we create the anhydrous mixture?
We heat it?
That's right.
Hey.
What will happen if we put the temperature too high?
We'll burn the mixture and create a nasty smell.
Correct. Now, what temperature shall we put it on?
Medium?
Yeah, that sounds about right. Let's go with that.
Notice how it's becoming thick. That's because we're starting to get syrup, which is like caramelized sugar. It's the best thing in the world. It's becoming anhydrous. The glossy simmer right here, it's because it is starting to turn back into sugar. See how it just drips off of the spatula? Off the spatula? Like that? It's starting to become solid again. Because it takes forever. So, what have we created?
We have created an anhydrous mixture.
Somewhat.
Sort of.
Close enough, I guess.
It will be anhydrous.
It will be anhydrous
mixture.
if we were to keep going, but
And going.
we kind of don't want to burn the pan.
Yeah.
See, look, it's all syrupy now. It's like corn syrup. With no corn. With no corn. Grab a can of it really quick.
Children of the corn syrup.
Oh! Hey, we're going to tell you about heat vaporization and vapor pressure. Well, what the heck is heat vaporization?
Well, it's measured by using constant temperature, which means something has to be added to the solution before vaporization can occur.
To raise the temperature, heat is added. The whole point of vaporization is to measure the amount of heat added so it can remain at a constant temperature.
Water has a heat vaporization value of 40.65 kJ per mole. A considerable amount of heat, energy, 586 calories, is required to accomplish this change in water.
Now, we'll tell you about vapor pressure.
Vapor pressure is given by a vapor in an equilibrium with its solid or liquid phase. There is no evaporation yet at this point.
Evaporation!
And cut.
Now, we're going to tell you about some new research in the area of water. The Water Research Foundation is a huge sponsor for research in the water community.
They have released a study of findings that addresses effective removal of bacteria and toxic algae from drinking water.
The presence of things that contaminate the water are growing. Cyanobacterial bloom continues to increase.
These things are continuing to grow more, and changing climate, continued urbanization, and certain other triggers.
The latest project by the WRF provides a guidance to the water utilities.
It shows them how to optimize the water treatments to better remove the toxins.
You can learn more about this by going to businesswater.com and searching removing toxic algae.
This is how you welcome a dog.
It's not. We're going to be doing a lab over Brownian motion.
Brownian motion is the result of collisions between small microscopic particles
Brownian motion!
And water.
Now, we make it really fun. Like this. Like it. 2 spoons. Who wants to mix? Ta-da!
We measured in calories, which is just a simple unit of energy. 1 calorie is a little over 4 joules.
A joule is
Are
another
you
common.
calling me fat? What?
This is the molecular structure of water.
As you can see, there are 2 hydrogen atoms for each oxygen. Oh wait, it's carbon dioxide. This leads to hydrogen bonding. As you can see, there are 2 hydrogen atoms for each oxygen. This leads to hydrogen bonding.
Hydrogen bonding is when a hydrogen atom is of 2 atoms compared to the only one. So that it can act as a bond between them. We have to
Tell you about polar covalence.
The covalent bonds is formed by the complete transfer of valence electrons between bonded atoms.
Complete its outer shell with 8, making it full.
As we go through these lessons, you'll also want to know about the heat of fusion.
I can't find it.
Okay, so for the first time ever, we have the wild Sammy caught on camera with her water bottle.
We're here to throw the bat to the knife.
We are going to introduce water Sammy into her life.
I don't care. Don't you backtalk me.
Look, where do they want to sit? Hey, we're gonna tell you. We'll see. You start.
Oh, alright, my assistant will fill the glass of water and add a tablespoon of water of sugar to it.
Are you hungry? Did you eat lunch? Velocity. Velociraptor. Did you eat lunch?
Yeah.
What time did you eat lunch?
Oh.
Probably before 12.
A spoonful of sugar.
We're going to be learning about the Tyndall effect, and we're also going to be learning about colloids.
You may be wondering what the Tyndall effect is.